Welcome everybody to this ESCoE seminar on the topic of network constraints on cities, careers, and economic resilience, which is going to be presented by Morgan Frank. Just before starting, just to say that the seminar is being recorded and this is going to include the Q&A. And my name is Juan Mateos Garcia, and I'm Director for Data Analytics at Nesta and Topic Lead at ESCoE for New Data and Methods to Measure Innovation and Productivity. The way this is going to work is I'm going to be briefly introducing Morgan now, and then Morgan will talk for around 45 minutes about his research, and then after that we will have a Q&A. You should add any questions that come up as in the chat as we go, but we'll only be answering questions at the end. So yeah, that's how this works. In terms of introduction to Morgan, Morgan is assistant professor at the School of Computing and Information in the University of Pittsburgh, and he's a PhD from MIT Media Lab. He's in my opinion, doing some of the most exciting and innovative and policy-relevant work in the intersection of economics, complexity science, and computer science. He's looked at issues like automation, emerging technologies, and what we're going to be focusing on today is structure of labor markets, resilience, and worker mobility. I think that these are very important questions for audiences in the UK. Obviously, as we develop leveling up agendas, explore pathways to a more sustainable economy, look for ways to minimize the disruption caused by automation, be able to have very strong evidence about structure of labor markets and how they might be able to respond to these shocks, and also how policies might encourage transitions to more innovative and less polarized labor markets. These are all big questions for us. So really looking forward to hear what everything that Morgan has to say about this. So without further ado, I'm going to pass over to Morgan and let's start the presentation.
All right, thank you so much for that great introduction. And thank you for this opportunity to share some of my thoughts on network constraints on cities, careers, and economic resilience. So in this talk, I want to address a few questions, but the big picture question is, how do workers' skills shape their mobility? And by mobility, I mean a few different things. For example, their career mobility, but also their spatial mobility. So let's talk about a few more details here. So one of the things I'm interested in is, how do skills shape workers' career trajectories, and are we missing out on some important information if we use traditional labor categories that are a bit more abstract? So for example, only talking about workers or occupations as cognitive or physical, rather than drilling down to the specific skill sets that workers have or the specific skill requirements of different occupations. With this refinement and looking at more specific skills, do we gain insights into how workers move about within their local labor market? In this case, I'm going to be thinking about cities as local labor markets, but also how workers move between different labor markets as well. In the end, we'll investigate how our insights into skills and to the structure within urban labor markets gives us some new insights into the economic resilience of US cities. So why focus on cities? Well, cities in many countries are centers for innovation and productivity. And Harvard economist Edward Glaser has this really well-cited book that describes some of the many ways that cities are a rising tide that float all boats type of place. So for example, he talks about how regardless of your demographics, your skill level, your level of education, you tend to be better off in large cities compared to your peers in other cities in the US. However, Ed notes that this need not be the case. He says that not every city will succeed because not every city has been adept at adapting. In this case, he was talking about adapting to technological change in the age of information. And actually, when Ed was writing this book, he was really looking at analysis in the US from the 70s, 80s, and 90s. But there's some concerning trends in more recent decades that call into question how long lived will this triumph of the city last. So here, for example, on the left is some analysis from MIT economist David Otter. Here, each color represents a different decade. The x-axis tells you the population density in each US city. Population density is pretty correlated with population as well. Y-axis is telling you the change in employment share over that decade, comparing low income workers, middle income workers, and high income workers. And what David noticed, which sort of challenges the usual ideas about urban development and regional economic development, is that although in earlier decades middle skill employment was growing in large cities, that trend has largely deteriorated in more recent decades, and instead only the most highly skilled workers are moving to cities. So this was a shock. I remember talking with David after he gave this talk at the American for one of the big national economic bodies in the US. And this was a real shock to him. Since then, a lot of other researchers have been trying to understand the many factors that might contribute to the deterioration of the triumph of the city, and technological change has been pointed to as potentially one of those major factors. From my own research, I'm going to just mention this study briefly, but not really talk about too many of the details. You can go check it out for yourself if you want to learn more. But from my own research, we combined different sets of occupation level estimates for risk of automation with the employment distributions in each US city to calculate this weighted average impact from automation in each US city. And we found that regardless of the set of occupation level estimates that we plugged into our analysis, the same trend popped out the other side, namely that smaller cities face greater impact from automation in the foreseeable future. So what's going on here? Why is it that technology might differentially impact workers of different skill sets or different education levels? Well, actually, the prevailing theory for technological exposure and labor trends as a result allows for this. So the prevailing theory is called skill-biased technological change. And broadly, this theory says that highly skilled cognitive workers tend to be augmented by cognitive technologies, while low-skilled physical workers tend to be substituted by physical technologies. So as an example of this, machine learning, data scientists and software developers tend to be augmented by technologies like machine learning, while truck drivers stand to be replaced and automated by technologies like autonomous vehicles. So when you think about this, though, I think that if you use the traditional categories for describing workers and occupations from the skill-biased technological change literature, it forces you to put really different occupations into similar bins. So here, I want to highlight this with just two examples. So for example, if you consider medical surgeons and civil engineers, these are both highly educated workers that are highly paid. This is cognitive, non-routine work, but these occupations are really very different because they require very different skills. You can see this, for example, because no workers transition from being a civil engineer to being a medical surgeon or vice versa. There's no skill transferability there. This might really matter for understanding technological change in the future of work as well, because these workers in these occupations are likely to interact with very different technologies moving forward. Another well-documented example from the literature comes from Boston University economist James Besson. He found that surprisingly, national employment for bank tellers actually rose with the increased adoption of automated teller machines, ATMs. And he pointed to a few reasons to help explain this, but one of the big factors was that the skills required to be a bank teller fundamentally changed from requiring workers with money handling and numeracy skills to instead requiring workers with social skills. And this is because the bank tellers of today act as customer service and sales representatives for bank goods and services, while ATMs do the bulk of the money handling and money transactions. So in both of these cases, if you wanted to understand how these occupations would interact with these technologies, you would need to understand the specific skills and how those skills change in light of these technologies. So to try to accommodate for this level of granularity, I've been thinking about the US labor market as this multi-layered complex system. So here, let me describe this briefly. At the top here, we have different local labor markets. So these might be individual cities, but also rural areas. These labor markets don't exist in isolation, of course. There's flows of goods and ideas and workers between all these different places. If you wanted to describe any one of these labor markets, any one city, for example, a natural thing would be to look at the employment distribution in that city. But if you only look at this employment distribution, you might miss some important structure within that labor market. For example, mapping out the opportunities for career moves for workers, and in particular, identifying the workers who are stuck and perhaps would have a hard time finding new employment if their current job is lost. What features explain these connections and might help us explain what type of career mobility is available in your local labor market? Well, workers' skills and the skill requirements of occupations are an important factor. And of course, skills don't exist in isolation either. We know that skills get bundled together. For example, complements tend to get bundled together. So a worker who is good at math and good at computer programming is probably more valuable than a worker who is good at just math or just computer programming. And this would be an example of skill complementarity. So here we have our multi-layered complex system. We can see there are connections within each of these layers, but also connections between each of these layers. And I've been spending a lot of research effort trying to both describe each of these layers empirically and better understand the dynamics when you consider different subsets of these different spaces. It's a really great strategy for writing papers if you're a tenure track assistant professor at the University of Pittsburgh. So in particular, one of the things I hope we can do with this framework is better understand how microscopic changes to demand for different skills, abilities, or tasks, for example, from technology, how do these microscopic changes accumulate into the more macroscopic labor dynamics that we talk about today? Things like job polarization, wealth inequality, and changes in urbanization. So we have this paper called Unpacking the Polarization of Workplace Skills and Science Advances that describes this network of skills. This isn't the topic of today's talk, but I wanted to point it out in case you wanted to go check this out yourself. We also have this paper in PNAS that you can go check out to understand our vision for this whole system in one complete coherent view. So for today, let's start by looking at the space of occupations and trying to understand this network of occupations, and in particular, how we can use skills and occupation skill requirements to map out this structure. So to begin with, I want to give you this specific example here to try to highlight why we need to focus on granular skills and do more than just talking about occupations as cognitive or physical or routine or non-routine. So here I've picked two US occupations. We have medical surgeons and air traffic controllers. And I'm sure that each of you would agree with me that these are very different occupations. To try to confirm our belief here, I'm using skill profiles from the US Bureau of Labor Statistics. They produce this ONET database that gives us insights into the skill requirements, task requirements, abilities, and knowledge required for each occupation in the US. So here with these word clouds, I'm highlighting the skills, knowledge, and abilities that are most important to each of these occupations. The larger the text, the more important that skill is to that occupation. So you can see that the skills that pop out here kind of make sense for these two occupations, and also that largely the two sets of skills are really different. There's not a lot of shared text here between these two word clouds. So this confirms our belief a priori. However, I've also colored these skills according to if they are cognitive or physical. And when you aggregate these skills based on if they're cognitive or physical, you can arrive at this aggregate measure for how cognitive each of these occupations are. And at this aggregation, these two really different occupations appear almost identical. They have almost the same percentage of cognitive skills required. So to get over this, we propose using a more granular skills similarity score that accounts for both the shared skills, but also the union of all the skills required by these two occupations. If you squint at this a little bit, you realize it's really just Jacquard similarities. This is a pretty standard way of measuring similarity here. So, all right, Jacquard similarity is cool. Probably many of you have heard of it before. But is it actually useful? Does it actually predict labor dynamics that we care about? To investigate this question, we're going to use the US Census's current population survey. This is a nationally representative survey of the US, where participants contribute to the survey over a few years. And if they change their occupation during their period of contributing to the survey, we will observe that occupation change. And so that allows us to look at the rate of job transitions between pairs of occupations in the US. To try to predict this job transition rate, we're going to use as a baseline model basically a random mixing model based on the national employment for each occupation in the US. And you see that the random mixing model does pretty well, but you do a little bit better if you also characterize each of these occupations using some standard labor categories from the skill bias technological change framework. So in particular, measuring how cognitive, how physical, how routine, how non-routine each occupation is, you get a little bit of boost in predictive performance. However, you get an even greater boost in performance if you instead use our more granular skill similarity score to help make these predictions of job transition rates. So this is pretty interesting. We do get a little bit more predictive performance here, but perhaps really we're just kind of splitting hairs here. And instead of just using 4 categories, cognitive, physical, routine, and non-routine, really we just need a couple more O-Net skills, 6 categories or 8 categories would do the trick and get to the same level of predictive performance. So to test this idea, we're going to run this experiment over on the right, where basically from left to right, we're randomly selecting a subset of all O-Net skills to calculate this skill similarity score, and then rerunning this model 3 and measuring the predictive performance. So what you find here is that the model's skill dramatically changes for the first 50 or so skills that you include in the skill similarity calculation, and then includes more modestly but steadily thereafter. So what this tells us is that this predictive performance is not the result of just 1 or 2 additional skills, but actually you really need this full set of O-Net skills, knowledge, and ability to get the performance we see out of Model 3 here. It also suggests that further insights might be gained if we continue to refine our skills data and more data on abilities, knowledge, and tasks that define these different occupations. So we were really pleased with this early result. And so we used this skills similarity score to calculate the similarity between every pair of occupations in the O-Net database from the US Bureau of Labor Statistics. And we modeled this as an occupation network. So here's what you get. Here, every circle represents a different US occupation. There's a weighted edge between pairs of occupations representing their skill similarity score. In truth, every pair of occupations has some non-zero skill similarity, but we filtered this network down to just the most similar occupations. This is just for visual purposes. In any analysis, we're going to use the unfiltered network where there's an edge between every pair of occupations. When we apply some clustering techniques to this network, we identify that on aggregate, there are 2 occupation clusters. When we look at the skills that are important to each of these clusters, it appears to be a separation between physical occupations and cognitive occupations. You can also separate these 2 clusters in terms of wages and also susceptibility to automation. So here, using automation estimates from the Arntz et al. OECD study, and also from the Fry-Osborne study out of Oxford University. So how do we use this occupation network to describe labor markets and to describe careers? So it's not the case that each US city supports every occupation that you might find in the whole nation. So here, to capture this, we're going to project cities onto this complete occupation network by coloring in the occupations with non-zero employment in each city. So Burlington, Vermont is a relatively small US city, and you can see these gray circles are occupations that don't have any employment in Burlington, Vermont. We're coloring in the occupations with employment in Burlington and also coloring in the connections between pairs of occupations with non-zero employment. So here you can see Burlington, Vermont, Boston, Massachusetts, and Pittsburgh, Pennsylvania projected onto this occupation network. How do we use this network to describe a worker's location in their local labor market? Well, you'll remember that each of these edges has this skill similarity score, which was predictive of job transition rates between pairs of occupations. This is from 2 slides ago. So to try to capture this a person's location and what type of career opportunities they might have in their local labor market, we introduce a measure that we call employment-weighted embeddedness. You can think about this like a node's weighted degree in their occupation. So what is their skill similarity to all the other occupations in the network, weighted by the employment share of each of these neighbors. So it's really capturing 2 things. How similar is your current occupation to other occupations, and how much employment is there already in these other nearby occupations? Now, it's not clear to us a priori whether this employment-weighted embeddedness should be a measure for complementarity or competition in the workforce. So for example, if you're in an occupation and there are many other workers with similar skills to you, maybe this means that you're in an area of the economy with a lot of positive spillover effects from agglomeration economics. On the other hand, maybe you're in a really competitive part of the network because there are many other workers with the same skill set that you're using on the job. And maybe this means that you have to compete with other people for employment opportunities. So to explore this question, we're going to look at 2 large-scale resume data sets, one from Burning Glass Technologies and another from FutureFit AI. Each of these resume data sets contains the career trajectories for millions of workers in the US. So what types of career moves might change a worker's employment-weighted embeddedness? To try to highlight this for you, I'm giving you my CV as an example. So there are basically 3 types of moves that might change your embeddedness. The first is you have the same occupation, but you move to a new location. The second is that you have a new occupation in the same location. And then the final thing is that you could do both. You could have a new occupation in a new location. So here, this is like moving to a different network. This example is like moving to a different node in the same network. And then this is both, moving to a different node and to a completely different network. So how do workers change their employment-weighted embeddedness over the course of their careers? Well, in both of our resume data sets, we find that workers tend to decrease their employment-weighted embeddedness over the course of their careers. So the next question is, well, why might workers do this? So to investigate, we're going to look at individual job transitions over these careers and compare the change in employment-weighted embeddedness for each transition to the change in wage that we would expect using employment statistics from the Bureau of Labor Statistics. In general, what we find is that changes that decrease your employment-weighted embeddedness correspond to bigger increases in wage. And actually, this effect is slightly stronger if you condition on worker relocation, so job transitions that change between different networks in different cities. We look at this with a little more detail in this regression analysis. So here we're controlling for things like source city fixed effects, destination city fixed effects. If your job transition doesn't change cities, then your source city and destination city would be the same. We also have year fixed effects. We have dummy variables for if your job change was a different job title or a relocation. We control for educational requirements for occupations and also for some more generic network measures for these occupation networks like the page rank. However, what we still find is that changes in your career that decrease your employment-weighted embeddedness correspond to increased wage gains over the course of a career. So what's going on here? And actually, we're not really sure causally what's going on here. It'd be really interesting for future work to identify some type of natural experiment to help us understand what mechanisms are driving these dynamics. But there are two theories that come to mind. The first is that this might be a worker-driven effect. Workers who have skills that are rare in their local labor market might be able to bargain for higher wages, just using a supply and demand argument. On the other hand, this might be an employer-driven effect where employers need workers with skill sets that are rare in their local labor market. And so they are offering higher wages to try to import workers with the skills that they need, that they can't find locally. If this latter case is true, then we might be able to see the symptoms of this by looking at, by comparing the on aggregate embeddedness in a pair of cities and comparing that to the flow of people moving between those pairs of cities. So to investigate these flows, we're going to look at both census migration between pairs of cities and using data from the US Census Bureau, and also looking at the number of emplaned passengers flying between pairs of cities according to the US Bureau of Transportation Statistics. Now, a change in address would contribute to migration rates, and it's usually thought that migration has to do with employment opportunities. Flights, maybe not so strongly associated with work, but still it's thought by the Bureau of Transportation Statistics that nearly 2/3 of flight travel in the US is business related. What about aggregating these embeddedness scores? Well, we're going to take a pair of cities, look at the occupations with non-zero employment in both cities, and look at the embeddedness of this occupation in city 1 compared to city 2. If the embeddedness is larger, then this denominator will be larger and the whole thing will be smaller. If the embeddedness is lower, then this whole score will be higher. So how does this aggregate on average embeddedness relate to these two different types of mobility? Well, as a baseline model, we consider the gravity model, which uses the size of each city combined with the distance between pairs of cities. And we find that we get a pretty significant improvement in predictive performance when we add in this combined embeddedness score. But more interestingly, you do even better if you look at the interaction between combined embeddedness and the combined size of these two cities. So this interaction effect is pretty significant, and the improvement in predictive performance is also noticeable. And actually, this effect is really clear just visually here. So here we're not controlling for additional things, but you can really see how the relationship between combined total employment and the spatial flows between pairs of cities really changes when you condition on this combined embeddedness score here. And this is true for both cases. So here, I think we've given a little bit of insight into what this middle layer of occupations looks like and what the connections between occupations might help us say about the flows of workers between different cities. But another thing I hope we can do is produce some new measurements and some new tools for forecasting important employment trends that might help inform new policies that bolster local workers' job security. So in particular here, here we see our multi-layered complex system again with the skill network on the bottom, our occupation network in the middle, and then different cities support different types of occupations on top. And what I pitched to you when we were looking at the cartoon version of this is that we could use this to better understand aggregate systemic changes if different types of removal occur within the system. So for example, the removal of skills, maybe from automation, or maybe a firm moves away from a city and that changes the type of occupations that are supported there. So in thinking about how changes to the system might impact the health or resilience of different economies, I'm actually inspired by related work in other areas of complex systems, and in particular in research from ecological modeling of ecological resilience. So let me tell you a little bit more about this. So here we have our occupation network from before. The network layout is a little bit different, but it's the concept is appreciably the same. So here we're looking at 2 cities projected onto the occupation network. This is just for example. We have Boulder, Colorado, and Detroit, Michigan. Now, when I compare these 2 networks, there are 2 differences that jump out to me immediately. The first is that Detroit, Michigan has more circles than Boulder, Colorado. That is to say that Detroit, Michigan has a deeper labor market with more unique job titles than Boulder, Colorado. And this actually makes perfect sense because Detroit is much, much bigger in terms of population than Boulder, Colorado. The other thing that jumps out to me is that there are parts of this Detroit network that are really densely connected. So here, for example, is a space of mostly physical occupations, and you can see it's just a complete hairball. It's really densely connected. And there's almost no part in the Boulder network that looks nearly that densely connected. So to capture this idea, we're going to introduce a new score that I'm calling just Occupational Embeddedness. This is just each occupation's weighted degree. So we're ignoring the employment share for each neighboring occupation in this version of occupational embeddedness here. So let me tell you how we're going to use occupational embeddedness to talk about economic resilience. In thinking about this, we're motivated by the highly celebrated job matching theory from labor economics. This theory won a Nobel Prize in economics in 2014. In its most generic version, you can think about a local labor market in terms of the employed people and unemployed people. And people move between being employed and unemployed and reemployed according to this matching function, which here is represented as just some generic M. So the question is, what should this matching function be? What is M? And many studies use a random mixing model between unemployed workers and job vacancies with this parameter allowing you to control the rate of transitions between those 2 states. Now, this is a really generic and a really abstract matching function, and the authors that propose this theory, they know that. They say that this formulation is a reflection at the aggregate level of the complex and varied patterns of hiring because it misses several heterogeneous effects that vary across different labor markets. And in particular, this formulation misses skill mismatch. So skill mismatch occurs when the job seekers in your local labor market do not have the skills to fill job vacancies that employers want to fill. In this case, your labor market will continue to have unemployment and will continue to have unfilled job vacancies until the skill mismatch is resolved. Our thinking is that our analysis of specific skills and our skill similarity scores might help us refine this matching function by incorporating more information about skill matching. So here to do this, we're going to make a few different changes to that formula you saw before. The first big change is that instead of having just employment and unemployment for each city, we're going to have employment and unemployment for each occupation in each city. The other big change is that instead of that matching function from before, we're going to allow unemployed workers from some occupation to become employed in this occupation J, mediated by the skill similarity score here. So this is the big change. Now, when you write out this system of equations, it's clearly an example of what's called a generalized Lotka-Volterra system. And if you've ever taken like applied math or dynamical systems in a first semester course, you probably talked about Lotka-Volterra systems. This is a really well-studied system for describing ecosystems and ecological resilience. So this was great. This meant that we could try to find some analogies from the ecological resilience literature to help us better understand economic resilience. And in our reading, we found this really great paper from Gao et al. In Nature that we're going to use really powerfully. So in this paper, they were modeling ecosystems as having different species of bugs that interact with different species of plants. And by looking at the bugs that interact with the same plants, you can create this bug network here. And what they found is that the density of connections within this bug network was enough to predict how resilient that ecosystem was to all different types of changes to the ecosystem. So the analogy we're going to make is that instead of bugs and flowers, we're going to talk about occupations and skill requirements, and then this bug network becomes analogous to our occupation network from before. Again, using math from this great paper, we can take our really big system of equations. So here, remember, for a given city, we have 2 equations per occupation, and we have a skill similarity score for every pair of occupations. We have these parameters, alpha and lambda, that I haven't even told you about. It's just a huge system of equations with tons of degrees of freedom. But actually, if you follow this paper, it all reduces down to just basically these 3 quantities that describe the average long-term expected behavior of each labor market. So let me briefly tell you what's going on here. First, we have this capital WC, which is really just a normalization factor for the size of the occupation network. We have the effective long-term employment for a given city, which is basically the current employment in that city weighted by that city's occupational embeddedness. You have a similar calculation for the effective long-term unemployment in that city. And then finally, we have this effective connectivity, which is basically looking at the density of connections across occupations in the US. This WF turns out to be really important for us, so we're going to give it a name and call this quantity job connectivity. So, as in ecological studies, is this connectivity measure predictive of resilience? To investigate, we look at US cities following the Great Recession. The Great Recession really took off in the last month of 2007 and officially ended before 2010, but you can see that most cities found their peak unemployment around 2010 or 2011 here. So here we're going to compare a city's job connectivity in 2007 to their peak unemployment rate following the Great Recession. What we find is that even if you control for several standard measures that you might use to predict resilience, things like the size of each city, the number of unique occupations in each city, or the Shannon entropy of the employment distribution in each city, we find evidence that job connectivity, that cities with greater job connectivity had lower peak unemployment and were more resilient during the Great Recession. So not only this, we also observed some interesting insights that allowed us to connect occupational embeddedness to the employment weighted embeddedness that we talked about earlier before. So let me try to describe this to you. So here you can zoom in on an individual occupation. So here let's consider financial managers. Again, this is just some node in the occupation network for each city, and the connections this occupation has might vary across each of these cities depending on that city's network. So for example, financial managers is highly embedded in San Francisco in 2015, but not necessarily as embedded across all cities in the US. So what we find interestingly is that even if you pick one occupation, let's stick with financial managers, for example, workers of a given job title across cities with different embeddedness scores for that occupation will earn different wages. Here, I'm just showing you the straight correlation, and what we find is that for financial managers, workers in a city where financial managers are more embedded earn higher wages than their peers with the same job title in other cities. When we do a more controlled analysis, for example, controlling for city fixed effects and year fixed effects, the local employment share for an occupation, or the educational requirements for various occupations, we still find this same evidence for this embeddedness wage premium. So this is pretty interesting. This is actually an area for future work. Basically here, greater embeddedness corresponded to higher wages, while we kind of saw the opposite trend for the employment weighted embeddedness. So we need to do some more work to try to understand what's going on here. I think what's going on though is that this embeddedness score, and in the context of resilience, we're talking about sort of out of equilibrium effects, while the employment weighted embeddedness and our analysis of careers will be mostly driven by equilibrium labor economics. But again, some more insights and some more work to be done here. So, okay, what about, so the Great Recession was the labor disruption to talk about basically up until a couple years ago. So what about the COVID recession? So this is an area of ongoing work, but I can share some preliminary results with you here. Here, for example, we're looking at the monthly unemployment rate for a few example US cities. You can see that they do really vary across time. here's the Great Recession, and then here's 2020. It's just this really unprecedented spike in unemployment. For the results I'm sharing with you here, we're using data up to May 2020, but of course, more recent and ongoing efforts are using data that are up to 2 months ago. So you can see at the time of this analysis, some cities were beginning to recover while other cities were still getting worse. In any case, similar to what we observed with the Great Recession, cities that had greater job connectivity in 2019 were more resilient and had lower unemployment rates in 2020 after controlling for city size. What about individual occupations? Here, I think this is probably the most interesting area for future work, building on this analysis. Basically, our job connectivity score averages over occupations in each city and measures how many connections that occupation has to other occupations in the network. The idea being that if a worker of an occupation that shares skill requirements with many other occupations in their local labor market, well, that worker might have an easier time finding new employment opportunities without reskilling or retraining if their current job is lost. So we're still kind of figuring out exactly how to do this with the data available to us in the US. Here I'm presenting basically two strategies for projecting state level unemployment statistics down to the city level. We're still working on this, but in both cases, what we find is evidence that workers of occupations with greater embeddedness are less likely to require unemployment insurance in 2020. But again, some more work to suss this out and be a little more confident in how we project state level statistics down to city level insights. So let me wrap up. In this talk, we talked about empirical skill profiles that describe US occupations, and we used detailed skill taxonomy, again from the US Bureau of Labor Statistics, to relate pairs of occupations, and found that we were able to make greater predictions about job transition rates between occupations. We used these skill similarity scores to describe US cities as occupation networks, and we found that workers tend to decrease their employment-weighted embeddedness in these networks over the course of their career. We found this using a potentially biased set of resumes. However, we found evidence that the combined overall embeddedness for pairs of cities was very predictive of both spatial migration and the rate of people flying between pairs of cities in the US. And this was using nationally representative data from the US Census and from the US Bureau of Transportation Statistics. Building on these ideas further and looking again at these occupation networks for each city, we borrowed some ideas from ecological studies of ecological resilience to quantify the economic resilience of cities, and we found that cities with greater job connectivity were more resilient during the Great Recession, and I presented some preliminary evidence to suggest that, again, job connectivity in cities is predictive of greater economic resilience during the COVID recession. So if you want to learn more about this body of work, we have a few papers that I pointed at earlier in the talk. Here's the complete list if you want to go check them out for yourself. Some of this work is currently under review, and I want to thank my team of collaborators on these two projects. It's a really varied team, includes people like Esteban Moro and Sandy Pentland and Tobin South at MIT, as well as Iyad Rawan and Alex Rutherford from the Max Planck Institute. So with that, I'll take any questions.
Thank you, Morgan. Okay, let's start with the questions then. And I have lots, but I'm going to be disciplined and wait until we get questions from the audience. We have one question from Oleksiy Romanko, and actually I would suggest before people unmute themselves to ask their questions, if they could also say their names and their affiliation, that would be great, so that everybody knows, I guess, where different people are coming from. So Oleksiy, over to you.
Hi, Morgan. Thank you so much for really fantastic and really enjoyable presentation today. So I'm Oleksiy from King's College London, and my short question is that have you studied predictive powers of your models in more details. For example, I was particularly interested whether you measured something like mean average prediction error. So whether the models built helped not only to retrospectively explain what's happened, but do they really help to, more or less precisely map out what could happen in the future?
Yeah, it's a really great question. So we were really more interested in a conceptual test and trying to test our theory a little bit more than necessarily maximizing the prediction. Of course, this is a great area for future work. And like I mentioned, when you use that Lotka-Volterra system for describing a labor market, there were a bunch of free parameters that I didn't even describe because they didn't end up mattering for the analysis that we presented in that paper. We could make a greater effort to try to describe these parameters. So things like the general unemployment pressure in different cities. We could probably refine how we measure skill similarity to use a similarity measure that is less generic than the Jacquard similarity. And also the skills data that we have, I presented some evidence that even that skills data is rather imperfect and that probably we could do better with better skills data there. So I think there's a lot of room to improve if you're trying to optimize for predictive performance rather than testing a theory like we did. I know that a lot of people are interested in this predictive work. Of course, some of the people who come to mind are folks like Doyne Farmer and Maria, who's at just moved to she just moved away from Oxford, and then there's Penny Mealy, who's still at Oxford. These are folks who are doing very related work with prediction in mind as well. So I think this is a great area for future work.
Thank you so much. Just a small additional question regarding Lotka-Volterra model. Do you think there is great potential for including emerging skills into your framework? Because my initial thought is that cities which have higher rate of emerging jobs and emerging skills would be able to, substitute kind of lost links with newly emerging ones. Thus, they would be able to, sustain the, better balance that cities that just lose some links in this concept.
Yeah, totally. I think that'd be great. It kind of requires innovation on the data front, though. If you want to measure emerging skills, our framework requires you to do that at scale, and that can be a challenge. So, for example, this whole analysis was focused on U.S. employment statistics and U.S. cities, mainly because the U.S. has some of the best data for doing this type of work. I'm not aware of similar data at the same scale for OECD countries or for European countries, for example, but I'd love to be proven wrong. So if anyone can point me in the right direction, that'd be great. So this is all to say that the type of data we're using here doesn't seem to be pervasive even outside of the US, let alone having a lot of longitudinal resolution. So this is a data collection effort where we need some more improvement there. But once we get there, I think that would really significantly improve predictions and the responsiveness of this modeling.
Thank you so much again for answers and for presentation.
Yeah, thank you for the question.
Thanks, Alexi. Do you have any? Do we have any other questions? Anybody want to jump in? Just raise your hand and. Okay, while people think about other questions, actually I had 3 questions, Morgan, and they are going to be covering the data side, the analysis side, and the policy side, just to think about the whole pipeline, I guess. So actually you were just talking about data, and I think I would be very interested in almost like your thoughts on sort of like what additional data, new types of data, new data that could be made available either by statistical agencies or the private sector, would help to expand this analysis and maybe address some of the gaps and issues that you highlighted are, I guess, questions for future work. So, and I'm asking this question also because we might have like some people in the audience from the Office for National Statistics who I guess we might want to encourage to think about what other data could they release to inform this kind of analysis.
Sure.
So that's like question one. The second question is about, I guess, potential confounders of the measures of skill similarity. Like, for example, to which extent could some of these results be driven by differences in the industrial composition of cities, like, and the fact that they might have industries which are more productive, more innovative, and employ people in occupations that have a higher degree of embeddedness, maybe because they rely on general purpose. These occupations rely on general purpose skills like computer science and things like that, that we know allow people to move a lot between different industries and different jobs. So I like the question around analysis. And then the third question around policy, I guess in the UK and obviously many other countries, we have lots of concerns around this idea of superstar cities and almost like growing concentration of economic activity in a small number of places, which is, I guess, one of the conclusions that was coming out from the second part of your presentation around resilience to economic shocks and what higher levels of connectivity in the local labor market do to improve resilience. At the same time, kind of like the first part of your story about almost like workers moving into looking for labor markets where they are less embedded because that increased their salaries, maybe went in the direction of actually favoring maybe smaller cities where there's less congestion or competition in the labor market. So I was wondering if you could say something about maybe almost like the extent to which, almost maybe your qualitative assessment of the extent to which these forces, the net effect of these forces is to favor larger cities, or is the net effect maybe helping to maybe in some ways help us rebalance us a bit away from that superstar cities taking over like all of the economic activity?
Yeah, sure. Okay, so these are three big questions. So let's start with the first one. What types of new data do I think would be useful? So I think there's a lot of opportunity here, especially to create similar data sets for contexts outside of the US. So again, clearly, I've been focusing on US data and US cities. So I'd be happy to be pointed in the right direction here. But my understanding is that there is sort of a new effort to create skills data for OECD countries. I'm thinking about ESCoE, European Skill Classification. I forget what the O stands for. My understanding is that this is a pretty new effort, and that I'm really excited about that and trying to explore that further. But my understanding is that the same types of employment statistics that we have for US cities isn't available in general for cities outside of the US. So for example, for cities in Europe. And I think that's really important because I'm convinced that cities are a better approximation for an individual labor market than say a whole state in the US or a whole European country. In the US, this is really clear if you just compare a state like Vermont, which is tiny, to say a state like California, which has at least 2 huge cities in it. So it doesn't seem fair to compare things at the state level or at the country level. The other thing is improvements in skills data would be great. The ESCoE data set that I described has a lot more detail than ONET does. And so I'm really optimistic about that feature of the data set. One thing though is that these occupational skill profiles that you get in ESCoE and also in ONET, they don't really vary by geography or by time that much. So that's an area for, again, improvements in data collection efforts. So for example, in my analysis, a software developer in Silicon Valley has exactly the same skill requirements as a software developer anywhere else in the US. And this is a limitation of the ONET dataset. Of course, despite this, I hope I showed you that our framework is pretty useful. Another thing is we made use of 2 large-scale resume datasets from Burning Glass Technologies and from FutureFit AI. And this is really a kind of a rare opportunity. I think that people didn't have access to data like this, even 5 years ago or 10 years ago. So this is a new opportunity, and it allows us to abandon this view of careers as these sort of, where are you right now? What do we think will happen next? And instead consider a worker's complete history to better understand what they're going to do next. And I think that there's a lot of room to improve insights using full data sets on full careers. So your second question was, are there potential confounders to our skills similarity score, and in particular, the industrial composition of cities? And I think that for sure, measuring the industries in a city would interact with the skills similarity score, because workers in the same industry are more likely to require similar skills. So for sure, there's going to be an interaction there. But I believe that our skills similarity score is actually higher up in the causal chain than industries. I think your skill set determines what industry you would belong to. And so we could perhaps do a little bit more to try to measure from a predictive standpoint, how much insight do you get from just measuring industry compared to skill similarity, which is of course more complicated, or what is lost in that scenario. So again, we could do some more effort to address that question from a predictive perspective. But again, here, our effort was really more conceptual than anything. Your third question, what about superstar cities? Does our analysis give us any insights into the next superstar city, or does it tell us anything about if large cities will continue to dominate while leaving smaller cities behind? So this is a really great area for future work. I think we need to do some more effort on this front. In our analysis, we were really careful to control for city size wherever that made sense, including things like using city fixed effects basically across the board in all the analyses here. So we were making an effort to control for that. However, we did not look very carefully at developing economies, or trying to look at younger cities versus older cities, or larger cities, smaller cities. We didn't look at that interaction very strongly, except in the migration case. In the migration case, we found there was a really interesting interaction between combined embeddedness and the combined size of a pair of cities. So we need to make a greater effort to understand the causal mechanism there, of course. So I do think, though, having added all those caveats and limitations, I do think that probably understanding the parts of your local labor market that have this density of connections, and understanding which parts of your local labor market are actually sparsely connected, could give you some interesting insights as a policymaker about where you should make your investments. So it's not exactly clear what part you should do first, but you could imagine that investing in creating incentives for employers to come to your city that would densify parts of your local labor market, maybe that's a good thing for boosting resilience. On the other hand, maybe that's a difficult sell for employers, because that low density means that there aren't many workers with skills in that area. So maybe it's actually easier to focus on parts that are already dense in trying to incentivize employers. So maybe you need to be more strategic than that. We need to make a greater effort to study historical trends to understand how to balance those two ideas and those two effects there.
Thank you, Morgan. And I think that raises very interesting questions about what tools could we develop to put this kind of information in the hands of local policymakers. We actually have been reminded that actually we don't have a raise hand function. So anybody who wants to ask questions, they need to say something in the chat. So just a reminder to do that. And actually we have Teresa Fariña with a couple of questions. So over to you, Teresa, and first of all, tell us your affiliation. Thank you.
Thank you. Thank you very much. Great seeing you again, Morgan. I'm now in Maastricht, no merit. Very quickly, I wonder why you call it embeddedness instead of relatedness, because it might create some confusion, because in the literature of relatedness, we already have some evidence related to what you presented here today, which might be useful to communicate, to discuss complementarities between these two literatures. How would you relate what you have here with, for instance, evidence that we have that the three types of relatedness, so complementarities, similarities, or local synergies, all of these seem to prevent unemployment. But in particular, local synergies, which includes knowledge spillovers, demand effects, and other type of relationships between occupations, they seem to have the strongest effect for preventing unemployment. How would you relate these two concepts? Thank you.
Sure. Yeah. So it's a great question. I think there's a lot of analogies between these concepts of complementarity and similarity already in the relatedness literature here. Here we wanted to create we wanted to use a different term because we're trying to distinguish between two different types of embeddedness here. We also are trying to reference a sort of simpler concept than some of the relatedness literature in terms of the complexity index scores you see all the time in that body of work. So for example, you could imagine looking at the bipartite network between cities and occupations, or occupations and skills, or even cities and skills, to measure a complexity index score, and then correlating those with the method of reflection, and try to correlate those scores with like GDP or GDP growth. And there's tons of people probably doing that or have done that already. So I think there's a lot of similarity in terms of concepts, but kind of what we're getting at is a little bit different here. We're really focused on skills and how your location in your network might impact your opportunities and the health of that local labor market. So it's, of course, not to discount all these existing concepts from the relatedness literature, but I think the point we're making is different and adjacent to some of these other concepts and their uses.
Thank you, thank you. I might contact you soon because I think there's a lot to catch up since MIT.
Yeah, of course.
I'm also working on this, and yeah, I'll contact you soon. Thank you, Morgan.
Awesome. Thanks, Teresa.
Okay, so I think we are running out of time. So unless anybody has a very last final quick question to ask, that you can put that in the chat. I think we're gonna start to wrap up. And I guess, yeah, the main thing here would be to thanks Morgan for a fantastic, very inspiring presentation and a really great example of like amazing interdisciplinary work, which like incredible policy applications, and obviously lots to think about on the back of this, and really looking forward to see how this agenda of work develops in the future. So thanks so much, Morgan. And I guess, yeah, just to conclude, to say that we have in the next ESCoE seminar, we're going to have a presentation on new index number methods in consumer price statistics. This will be Thursday, the 10th of February, at the same time as here, 12:30 to 1:30, and the presenter will be Kevin Fox. So thanks, everybody. Thanks especially to Morgan, and see you at the next one.
Thank you again for having me. This was great.
Thank you.